Thank you very much for having me. It's an honor. Thank you very much, Marco, for making it happen for me to come here and present to this awesome folks, awesome people. I'll be happy to chat with you about some of the work which we are doing at Amazon in AI. But before I do so, I'm going to reiterate a little bit about what AI is, where things are, lose a couple of opinions I have, because otherwise I'm gonna not be able to sleep right in the night, and then dig deeper into what we have. Let's start. So this is the agenda. I'm gonna talk about what is artificial intelligence. I'm gonna talk about industrial revolutions. So we are going through one right now. I mean, even though if we potentially don't feel it, or maybe we are feeling it, I'm going to talk about the fourth, which is what we're going through, and a little bit about the previous ones. About the core technology, why is AI working finally now from the industrial perspective, a little bit of my background, and then I'm going to compare AI work from 97 and 2017, so 20 years later. And then basically also something we're talking about, a lot of you are entrepreneurs, starting up something. Why is Amazon interested in talking? I mean, why am I interested to talk to you guys? Why is Amazon interested in talking to you? And where do we feel that we need help as Amazon? I mean, this is just too big of a market. We'll talk about this one. And then AWS services, the history and how we lead up to this, and then some use cases. All right, let's start. Artificial intelligence, Wikipedia says AI is intelligence exhibited by machines rather than humans or animals. Any device that perceives its environment and takes actions that maximizes chance of success at some goal. And AI means when a machine mimics cognitive function that's humans associate with other humans' minds, such as learning and problem solving. Important for me is that we're talking here about learning, and it's important for me to talk and reiterate that we are perceiving, we're not only solving a problem in the vacuum, but also always in AI, solving a problem in a context of something else which is happening. So, simplified, a system or a service which can perform tasks that usually require human intelligence is what AI is. All right, so history. You saw that, I mean, this is Kevin Binns. We saw that before in other presentations, I think. So the link here, so the 5 tribes are symbolists, connectionists, Bayesians, evolutionaries, and analogizers. And you see that basically each tribe has their time to come. They come and go, and they come again, and so forth. So if you look at deep learning, backpropagation, we talk about it today. It was there before. I mean, before 70s, if you see this, I mean, we talked about neural networks before. So, and then basically we had a time where more statistical methods come up. The Bayesians came up basically and surpassed the neural network people, for example. And then you see that the people who are working on symbols had a big portion in the cake here. And here again in the 80s, and so forth. So today we see that, I mean, after some time where the statistical methods were taking more or less taking over certain things, and then basically the neural area, I mean, is now covering the majority of what we use for artificial intelligence. All right, the challenge for artificial intelligence is usually scale. Alex talked about earlier that we can do today what we can do today because computational power is where it is and data is there. So data is important. We need to be able to take that data, throw it against machines, and then we take basically that and predict we make some decision. So today we have petabytes of existing data. We have data which is generated from the web. We have data which is aggregated by customers inside AWS, for example, for their own users, etc. Training, we have tons of GPUs finally available for use on this one. I mean, so CPUs did not scale fast enough. Now GPUs are helping us to get to the next level. And also, we are not reinventing the wheel all the time again and again. Platforms came out. That's also very, very critical. And then, yeah, for the prediction, we have GPUs and CPUs. We don't need to buy servers to run certain AI tasks. We can build something which is completely serverless, and then allow the AI to be trained or predicted, and then depending on the need, we don't pay hardware which is potentially idling around. So that's an important component as well. So the cost factor here. So the promise of artificial intelligence is innovation, obviously. So we are allowing ourselves to utilize AI to add new features to existing products, and also to allow for new experiences and product categories. We're going to get to some of these examples before, but also some things which were not possible before are finally possible, which is awesome. So let's talk about Industrial Revolution 1, 2, 3, and now the fourth. So in the Industrial Revolution, basically you see that there is a shift, mostly of the workforce. Let's talk about this one. So in the mid-1700s, to mid-1800s, we had the transition from hand production methods to machines, steam power, machine tools, and the rise of factory system. Early 1900s was the second one, where we had the transition of using advanced using advanced chemical manufacturing and iron production processes. So that was what enabled us here. Mid 1900s, then the assembly line, Ford building things on more efficiently in a factory, and then early 2000s machine learning is finally ready for prime time. So we're moving, I mean, if you look at this, we're moving from some things which needed the hand to some things which can be automated, which we used to need to our brains for. So we can focus on higher level problems. So that's basically what machine learning is enabling us today. The same way like machines in the mid to 1700s were able to enabling us to deal with higher level problems at that point. So AI core technology, why does it work? We heard that a couple times before and now as well. So 1954, this is an example in language technology. 1954, IBM and Georgetown had the first machine translation system. They built, Alex, correct me if I'm wrong, but I think it's 56 words vocabulary system translating from Russian to English, was it? Roundabout? Yeah. And that was awesome stuff. And of course, the military in the US was super interested in this because, you know, the how do you call that, the Cold War and so forth. So that was basically something which was interesting for them. And then the second half of the 60s, John Pierce, highly critical report on language technology published, funding languages for decades, so the funding slowed down quite a bit. You see that in the mid-70s to the mid-80s, there was the US government slowed down the funding quite a bit. And then in the 2000s, companies came out with solutions. Small companies, large companies. I think one of the, I mean, most common. This is an image from The Economist. So I mean, there's obviously so much more stories to tell in the 2000s. But I think one of the big stories is Google coming out with a statistical machine translation in 2007, 2008. Siri came out 2010, 2011. Google then is now changing many of the languages towards neural machine translation. Not all of them are yet, but it's going as far as I understand. Microsoft, the speech recognition is reaching human parity. I think IBM and Microsoft are like fighting on the top level. I mean, I think IBM presented in the last interspeech an error rate of 5.1. Microsoft presented an error rate of 5.8. I mean, all in all, to be said here is, I mean, the quality of the speech recognition gotten really good. By the way, just want to, I mean, do a little bit of an overlay here. You see that when the US government research was funded, there is a slowdown quite a bit in the research community, of course, as well. So speech recognition, this is the qualities. I mean, the higher up, the more error rate, and this is a log. This is a log on a log scale. Again, this is from The Economist, and they borrowed that from Microsoft research papers. So you see that the switchboard task, for example, used to be super difficult. 93, it was almost 100%, and then in the 2002s, I mean, it was somewhere in the, I think, like 35 or so %. And then other tasks came: broadcast speech, switchboard on cellular input, meetings, and so forth. So the quality increased quite a bit. I mean, this looks like a linear going down, but don't forget this is a log linear scale here. So improvement is getting better very quickly. Another example in machine translation. The phrase-based neural and human translation side by side. Basically, if you look at what we have here, Google Translate versus human translator versus statistical translation. So the neural network is basically closing the gap between human and neural quite a bit. Okay, my experience. So 89 until 92. I started my first company in Aachen, in Acme Computer GmbH, and then I started an AI company in 99. Actually, the work on that was before. I started in 96 with some of the students of the institute where I started with. One of them started Google Translate thereafter, Franz Och. So building AI platforms at that point, and today I am with Amazon AI. So I can tell you a story or two about how it used to be difficult in building AI systems before, and how it is today. My research topics: speech recognition, machine translation, natural language understanding and reasoning, computer vision, and process automation. I mean, the first two are my since 22 years, my bigger focus than the other ones, but those are interesting for me. So, AI solutions. I mean, something which needs to be said today. The cost of developing AI solutions, whether it being computer vision, speech recognition, and so forth, is less than 10% of what it used to be. Today, 1-2 people can build speech recognition systems which can look really good. It used to be when you have to have a speech recognition system to be developed, you have to have a small army of people to work together on building acoustic modeling here and this and that. So this is much more difficult. It used to be much more difficult. Data is available as well. So we have a lot of data. I mean, if I remember, my first statistical translation system was trained on 16,200 sentences. Today, we're talking about 16 billion maybe or more of words or sentences. I mean, so we're talking about huge amount of data more which we can learn from. The focus was a lot on the algorithms. Today, the focus is quite a bit on data and data management. If you start a company today, you live off of your data. You don't live as much of your algorithms. The algorithms are more or less open source. You can go and get them, whether it being TensorFlow or MXNet or anything based, and you see that basically people are very open in sharing the algorithms. Where do I see a space? I mean, the AI space is huge, and all the big companies are trying to hire to solve the problems they see. But there's so many things which are left untouched, especially if it comes to special domains, user experiences, and specialized data. I mean, the big companies are not always covering everything which is necessary. So if I would need to start a company today, I would probably pick up a domain, focus on this one, and build my domain knowledge with my team, and then see how things go from there. I mean, whether it being, I mean, like growing quite a bit, building maybe a few additional layers of platforms underneath, and so forth. So the advantage is that large enterprises, oftentimes, they're very open in their algorithms and how they are developing their platforms. So you can go into GitHub and get whatever they use for their platforms there and get it. Also, general data, I mean, is more or less available, so you can you don't need to work from scratch there. All right, now I'm gonna get to Amazon. So we have thousands of Amazon engineers and scientists which are focusing on AI. I mean, everything started basically in the mid-90s in the fulfillment and logistics. We wanted to, I'm saying I just joined a year ago, but you know. But I mean, Amazon wanted to optimize their processes to minimize the cost in the warehouses, to basically be able to offer prices, I mean, basically to make prices cheap for the customer as well. That's number one. Number two, yeah, I mean, the fulfillment, so the logistics was expensive, and yes, the experience for the user, so the speed. So at the end of the day, having non-optimized processes, non-machine learned processes means also a longer wait time. I mean, we promised, or still are promising our customers, rapid delivery, right? I mean, we used to talk always about 2 days. Now we're talking about 1 day, overnight. We want to go into the hours and minutes. I mean, as soon as we can deliver something to you, something you can touch directly to you, that's important to us. Of course, if it's digital goods, you need to have it immediately, but I'm talking about physical products. The next thing which came in end of 90s is, I mean, search and discovery. We want to make it easy for you to find what you like. So that's important, so that we can make products which are potentially relevant to you, visible to you as soon as possible, and show you maybe things which you don't know that you know, but you might think is valuable. I mean, that's something which Amazon, I think, is doing an awesome job in. And then taking products which we have inside Amazon and enhancing them with AI is the third step. I mean, everyone heard about Alexa and Echo, for example, or the tablets, I mean, which have now Alexa in it or something like that. So this is an example for those. And now we are working since less than a year on taking what we learned over the years and making it available also for anyone who needs. So taking AI and making it a platform for everyone to work on. So this is my area, this Amazon AI. I mean, we want to democratize artificial intelligence, and here are a few services which I want to tell you about. So it's 3 layers of services. One, we have the AI services, or managed services, if you want to call them that. Then we have the AI platforms, the AI engines. The AI services are things which we basically want to talk to the engineer or entrepreneur, which does not have necessarily scientific background, but they want to solve a problem which they know there is AI necessary. The second layer is AI platforms, where we say algorithms come here. I mean, algorithms, I know what kind of algorithms I need, and I know what data I have, and I need to just connect the 2 things together. The AI engines is for the people who really are machine learning scientists or are planning to be machine learning scientists. They are interested in the layer which is basically 1 level up from the hardware, and we have hardware which our AI stuff works on, of course. All right. Where do we use in general the where are our services used in general? So image understanding, speech recognition, natural language processing, and autonomy are probably the 4 biggest areas of utilization where our services are being utilized. And you can see that deep learning, the deep learning activity within Amazon, I mean, they grew quite a bit in the last few years, like the market did. So, all right, let's go step by step. So Amazon Rekognition, let's talk about this one. Amazon Rekognition is a deep learning-based image recognition service. Search, verify, organize millions of images. That's basically the idea. We want to have a service where you can upload an image, and the system is supposed to identify object and scenes. It should identify facial features, and then is able to compare images, faces with each other, and then facial recognition. So you see a lot of face-based, user-based, user-centric identification in here, which is relevant. But let's talk about the different things. So recognition gives you, if you have a picture like this, information out of the picture, like it sees a skateboard, it sees that it's about sports, it sees that there's people in there, person, parking lot, automobile. I mean, so it sees basically the objects around and gives you basically for each of these things which it identified the classes and how good or how confident it is about this. Also things, facial detection, I mean, it will tell you if it sees a picture like that, it looks like a face, it appears to be a female, smiling, appears to be happy, wearing eyeglasses, wearing sunglasses. So you can use a lot of things. You can basically use that as an input for a lot of applications, right? I mean, especially if you're talking about interpersonal applications or social media or anything of that, there's a few applications you can think about. What is very much a challenge is to identify people's faces that they are basically the same, right? I mean, the image to the left and to the right, we as humans know that, yeah, most probably that is the same person, but the features are looking very different. Lighting is different, they're looking differently into the mic, into the camera, they have the faces differently, they might have shaved or not shaved. I mean all kinds of information, makeup, hoodie, not hoodie, anything of that. I mean, this makes a difference, and we can still identify that. Also identifying from an image and finding a person inside a set of images or set of faces is something which we offer. So use cases in recognition: digital asset management, media and entertainment, travel and hospitality, influencer marketing, systems integration, digital advertising and consumer storage, law enforcement, public safety, e-commerce and education. All right. So next thing which I want to present is Polly, is the next one in. Polly is a text-to-speech service. It's based on Innova text-to-speech core technology, which is a Polish company which we bought a few years back. You can see the link here to the service, and we have the portfolio there. So it converts text to lifelike speech. It's fully managed, so you don't need to install anything and so forth. We have 47 voices. We have 24 languages covered. I think now it's 25. I mean, it's growing. And it has low latency and is in real time. The pronunciation quality and the voice quality and pronunciation is something we take pride in. We do automatic accurate text processing, intelligible and easy to understand, and the semantic meaning to the text we can tag. I'll get to that in a second. Customized pronunciation is possible as well. The advantage of us being Amazon, we have a couple books in our databases, so we can learn from textual things. We have also a company. We have also an arm which is called Audible, where basically books were read back by a human. So this is a huge value for us to learn with, right? And it exists in so many languages. So that's good stuff. Let's take a listen.
Was beginning to get very tired of sitting by her sister on the bank and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversations?
So you hear that there is prosody, which, I mean, like there's a tone, there is depending on what is being spoken, whether it is how do you call that, basically if it's basically the voice of the person you speak about, what do you call that? Yeah, anyway, I mean, so then the tone is different, so that you can basically identify without even a visual feedback what is part of what the lady was thinking and what is part of the actual story around it, for example. And then, yeah, it sounded very natural, I think. So to be able to do that, we have to do a lot of automatic accurate text processing. It's not only taking the text and like throwing it into some converter which takes the text and converts it into phonemes. There is more necessary. We need to understand what is the textual context of this one. An example here is, can we hear that? Let's see.
We live for the music live from the Madison Square Garden.
Wait. I don't know why the Seattle example doesn't work.
We live for the music live from the Madison Square Garden.
So the second example, we live for the music live from the Square Garden. I mean, through the context, it will figure out how to pronounce the word, the four letters, L-I-V-E. But in the first example, unfortunately, we couldn't hear it. It will identify what does W-A mean, what does 11 and the circle and F mean, and then basically transfer that into something which is understandable by us humans. Instead of saying Seattle, W-A, it's 11 F, it will say Seattle, Washington, and so forth. So it's easy to understand. Another thing is that we need to add semantic meaning to the text, like this number, for example.
Richard's number is 2,122,341,237. That's
a little difficult to remember. But if you do this...
Richard's number is 212-234-1237.
Depending on the context, it figured out basically what it probably is and reads it differently back to you. And then we allow the user to also customize pronunciations.
My daughter's name is Kaja.
Is not the right pronunciation, but it should be.
My daughter's name is Kaya.
That's what's supposed to be. So we allow the user also to do changes here. All right, where is it used? Media and entertainment, obviously, education, accessibility, content creation, telephony and contact centers, Internet of Things, and gaming. The research so language technology inside Amazon AI is my passion, as I had said before, and the research which we are, focusing very, very strong on for text-to-speech is the system is trained today on a few hours of speech and specific speakers, but we can adapt to large speaker databases. It's largely based on latest deep learning approaches. This is the current state of the art. And what a few advanced systems do, which I love to see more research in, is can be customized to specific speakers. For example, it would be awesome to have Brad Pitt speak in native Arabic, Chinese, or Korean in his own voice. That would be great. Some experiments exist already in the research, which is awesome. We should see what's going to happen there, but it's still bleeding edge. It's not yet ready for prime time. But I'm looking from the sideline and watching the research happen, and I'm very excited. Last one on that level is Lex. It's speech recognition and language understanding. It's based in part on Alexa ASR and NLU technology. It's basically a platform for anyone to develop their own application utilizing these technologies. So basically, people don't need necessarily to worry about the development of speech recognition or natural language understanding. They just need to implement in Lex their business logic, and then basically they can utilize what we are working on. Because the developer challenge is, we try to simplify the life for the person who wants to develop that. Security is an issue, availability, speech recognition, language understanding, and so forth. All these things we want to simplify so that you can worry about the actual application. So people can develop in an hour or two a prototype, in a week or two even a product with the Lex platform. Just to give you a little bit of a difference between Alexa and Lex. So Alexa is coming with an ecosystem. So it's devices. It comes with. So if you want to develop a Alexa skill, you're basically talking to the end customer. So we're basically giving you not only the platform to develop your skill on, but also the installed user base. We have millions of users. You can directly access them. You don't need to find a way on how to connect to the customer potentially. There's a lot of first-party and third-party skills already on Alexa. Lex is designed for a single-tenant chatbot to integrate with its own users. So banks and their users, if the banks want to use a chatbot for their own users, they don't want to go necessarily through all the Lex skills and all of that. They want to have a full focus. Something else is also Lex has a longer history. So Lex, as a Lex developer, you can develop personalization easier. You know what the user is doing. You can build some kind of history around that user and utilize it, which can go in months. Alexa usually focuses on the conversation which you are in, and then if the conversation stops, it's not necessarily designed for building a long-term conversation. So that might change, by the way, but just so we have in Amazon Lex we have intents, utterances, slots, and fulfillment. Those are the 4 components of relevance for us. Intents is an intent performs an action in response to natural language user input. You define example utterances and what they should be doing. You put it into Lex, and then Lex can deal with it, recognize the intent, and then activate whatever you tell it to activate. Coming from the utterances can be either spoken or written, like typed. to invoke that intent. Slots are data which are required, like parameters basically, which we need to extract out of your utterance. And fulfillment then is a way on how to connect whatever intent was recognized to some business logic, which basically, for example, does the actual order fulfillment, for example, or something like that. All right. I mean, I'm not going to go into details with this one. So basically, just telling that there is a lot of front ends you can go into, whether it's mobile, Internet of Things, web, chat, anything you want. I mean, you define basically as an application developer what is your interface to the user, and then basically the interface to the developer is you have a console, you have an API to either track activities or like monitor things and so forth, and then you can connect the Lex to other services within AWS, things like Cognito, CloudTrail, CloudWatch. You can we use AWS Lambda to basically encapsulate the business logic for you, and of course we use speech recognition and NLU, which is also powering Alexa. So that is basically that. We talked about this. Yeah, this is a different slide telling us similar things. So user input, Lex as a management system. Then you have AWS Lambda talking to other services, for example, CRM services, and so forth. Okay. So Amazon Lex use cases. So we have informational bots. For example, news updates and weather information, gaming, for game scores, sorry, and application bots to build powerful interfaces to mobile applications like book tickets, order food, manage bank accounts. Then we have applications like enterprise product bots to streamline enterprise work activities and improve efficiency, things like checking sales numbers or marketing performance, inventory status, and all of this can be utilized. We can use Lex to interact with the user. And then, of course, Internet of Things bots to enable conversation interfaces for device interactions, things like wearables, appliances in the car, and so forth. All right, we heard that. So just as an example here, Capital One, they said, as a heavy user of AWS, Amazon's Lex seamless integration with other AWS services like AWS Lambda and DynamoDB is really appealing. That was what Capital One said. And then a highly scalable solution, it also offers potential to speed time to market for a new generation of voice and text interactions, such as our recently launched Capital One skill for Alexa. By the way, when we allow the users to develop their Lex bots, we have also a conversion tool which makes it available on Alexa. So when you develop something on Lex, it's available for your own infrastructure, as well as if you want to, as convert it into an Alexa skill. So, speech recognition research, I mean, the area of speech recognition which I am looking at from the sideline is things like crosstalk, noisy environment, multilingual input, continuous improvement on existing problems, text-to-speech I talked about, and multimodality, maybe things like combining speech recognition and computer vision. I mean, if you think about Echo came out with a new device, the Echo Show. There is a camera built in, and it's really interesting to see multimodality in action. So then we have, because we're doing democratization, I probably am going to go faster on this one. Time is running. So we are building basically, if you think about, okay, here. So we're basically wanting people, if they are working on artificial intelligence, not to have to make a decision, oh, when you are using Amazon, you have to use MXNet. I mean, we're open to any platform. We have all the platforms on our machines, so you can basically pick and choose the platform you want. I mean, those are only a few. You have more. Apache, MXNet, TensorFlow, Cafe, everything you want at the end of the day. But we personally see that MXNet has a few nice things which might be valuable. I want to go quickly through all this. This is all here. I mean, if you're talking about MXNet, and why I like MXNet personally is I like that it trains relatively quickly. It scales with the amount of GPUs better than other platforms. So if you see, for example, from 1 GPU and 128 GPUs, the speed up is from it's 109 times. So it's almost linear. It's not quite linear, obviously, but because there is I/O overhead and all of this. But still, I mean, I don't know. We're talking about 80% efficiency with 128 GPUs is super cool, actually. So that's something why I personally like MXNet. We're supporting MXNet on many levels. So we'll see what happens there. Who is supporting MXNet other than us? I mean, it's not only Amazon. MXNet is not owned by us. It's supported like other platforms, but it's supported by many people. People from Apple, people from Amazon, of course. We have Microsoft people, Tesla people, Stanford people. So there's a lot of people who are supporting MXNet. And the way and the speed on how that is, picking up with features to other platforms is quite nice. All right, that's MXNet resources. I'm happy to share the links with anyone who's interested. Also with the links with the other services, Polylex, Rekognition, and other things. Let's talk about, I'm going to go quickly through, because I think we're close to the end, going through a few use cases where Amazon is using AI. Of course, the Echo. We're doing speech recognition and natural language understanding, dialogue here. We have the Echo Look, which is basically the Echo, but with the camera. And the Echo Show. My favorite right now. So we have a camera built in there. We have a screen. You can do your typical Echo things, but you can also do, chats with people who have an Echo, any Echo. You can do just voice conversations, chats, but also you can do video conversations, which is also possible. What you also can do with this thing is you can say, buy this, and then basically the system will identify, okay, you want to show me something, and identify that and find it in Amazon, and you can buy it from with this device, which is kind of cool. Amazon Go is another cool project. So we built a prototype in Seattle there. There's a store where you can go in. You sign in with an app. And then go into and pick up things from the shelves, put them in your bag, and leave the store. And when you leave the store, say again? Closed list? No, I don't think it didn't close. I'm not aware that it's closed. I don't know. If it's closed, that means there's something bigger planned. I don't know. So I don't know. But as far as I know, this is information which is a week old. So you can go in, pick it up, go out. Computer vision is helping. Behavior modeling is helping, so that we can identify, is everything all right, or something odd here going on, and all of this. Really cool project, actually. What we also have is X-ray. X-ray basically gets information about actions inside movies, people inside movies and all of that, which is actually kind of cool. You can basically see, for example, which actor is showing at what times in a movie, for example. You see these blue things here. And you can do searches. You can do X-ray on text input and Wikipedia and other things. And you can do you can do it also in if you are watching on Amazon's video, for example. If you're watching a movie, you can basically use X-ray right there and get information. For example, who is playing right now, who is on the screen right now, for example. But we do also other things like with partners or with customers. For example, early detection of diabetic complications. We have with customers like Congenital here, FDA approved medical imaging. People use our machine learning algorithms for like game statistics, and I don't even know what that is, but like figuring out which player is where, what kind of where they can play to, and all of this. Tracking of players. Autonomous driving, of course, is critical. Real-time per pixel object segmentation, we do that with some of the customers. So it's not only bounding boxes, but we can tell you where it's really the car and where it's under the car and so forth. So it's really cool. Centimeter accurate positioning with cameras only, with LiDAR. I mean, this is depending on what the customer really wants at the end of the day. Computational knowledge engines. Pinterest and us, we're working together on visual search, for example. We're supporting also the Pinterest lens and recommendation as part of what we do for many, many years. We're supporting other customers to do this in multiple languages. These are some references. So you see it's not only small companies, it's large companies which are building on top of our AI. They don't necessarily always rely only on our AI, but they build from where we stop basically and continue either with us or by themselves. So you see big companies here and universities actually, Stanford as for example. Then I think that's all I have to present for today.